now. It's going, supposedly.
That sounds great.
Yes, I think it works. And yep, I can hear myself, which I'm gonna stop because I'll go crazy. We are live. We have 0 viewers so far, but I assume that number is gonna change in a moment. Yes, it did. Wonderful. We have actual viewers. Hello, everyone. Thanks for joining us for this very impromptu stream. I guess we can do intros. My name is Marton, and I'm a developer advocate at JetBrains, and I can kind of navigate Gradle, but I'm never happy when I have to touch my build configs. So I have like an okay understanding of Gradle, and today we'll find out if we can fix up my Kotlin config project a bit.
Yeah, awesome. My name is Aurimas. Normally I go by Aurimas just because it's easier for people to pronounce, but I'm at Google. I work on Android X libraries, but I dabble a lot in the Gradle things. So, I'll try to share the things I know and the things I don't that hopefully can help you figure out what's going on in your build configuration time, and specifically the Kotlin conf app, and see what we can find there.
All right. So where do we start? You've written blog posts on this topic. So like looking at what's reasonable in terms of configuration time, and then if your times are not reasonable, how you can measure it, how you can benchmark it, and then profile it and try to figure out what's causing issues. So where do we start?
Yeah, well, I think maybe, for folks who are, maybe are slightly new to Gradle, I was going to very quickly run through kind of like the phases of Gradle and like why we picked this specific one. So Gradle has 3 phases. It has the initialization, where it effectively kind of like initializes the things it needs and collects the projects that are involved in your project. And then there's a second page that's configuration phase, which is largely going from what build.gradle files you have and the plugins you have to a task graph. And then finally, execution phase, it takes that task graph and actually runs it. And the important bit of why we're kind of like talking about configuration in particular is it's the thing that generally runs all the time, unless you have configuration cache on. And we can talk a little bit about that in a second. But the idea is it's a thing that runs a lot, and it's a cost that is usually a roughly fixed cost. So if you're gonna go and run it, you're paying that overhead even if you're changing like the tiniest file. There's that configuration cost that is going to be there. That's going to force you to do extra work, and so it's nice to kind of like go and optimize that bit. And since I mentioned it, most of you, hopefully, people who are watching, have heard and have enabled configuration cache, which is a tool that allows you to effectively skip the configuration phase and go straight to the execution. The way it works is that it runs a configuration phase for first time, and then it serializes it to disk. And so then you can just load it directly without having to recalculate it over and over again. So if you changed, a single KT file, in theory, you should never run configuration again. You're just modifying and running, and this, should be a good state. But then there's cases where things would invalidate configuration cache. So, it could be a fetch from Git. You could be in a ephemeral CI, or for example, you can be in the IDE and you're choosing which test to run, an Android test specifically. Today, that invalidates your configuration cache. And so you're going to be, if you're switching between test A and test B, you're going to be constantly invalidating and paying this cost. So, that's kind of where it makes sense to do that. So does that kind of make sense of kind of where we are and why we care about this?
Yeah. So for example, like when I'm running a Gradle sync, that would like definitely go through configuration, right? So that everything's built up and the ID can also like import the state of my project.
That's right. I think the part that's there's a little bit of a gotcha there with sync. That sync does not run, like it doesn't work at the task level. It uses a Gradle model API or tooling API, which still runs Gradle configuration, but it doesn't have this configuration cache today to be able to store it. So it will run configuration cache or configuration phase over and over again. So that's kind of like a thing to keep in mind, that even if you make configuration cache work, your sync will not today get faster. That is kind of more pending work that all involved ecosystem players to solve, but at the moment it doesn't do that.
Right, but when you're invoking Gradle for running your app over and over again, when you're running tests, as you mentioned, like all of those would also start with a configuration phase, and
Exactly.
that hopefully is cached.
Exactly.
Yeah. Tom in the chat is saying that in day-to-day usage, I've noticed that the config cache constantly gets invalidated, so it feels mostly useless. I guess that's another question of how you can track down why your cache gets invalidated at any given point in time.
Sounds like we're queuing up another session on this, because I do think it's a valuable conversation, and it's a valuable thing to teach people what to look. The TLDR is mostly you can look at your configuration cache report, and that gives you a lot of clues, but it's not a full list, and that's the gotcha, where we could have another hour session to talk about. But the idea is, if you make configuration faster, the configuration cache misses are less painful, right? So like that's the thing we're talking about today. I think helps you not to deal with the worst case scenario as much, because the worst case is less bad.
Yeah. Okay. So let's start with configuration times then. So the question in the title: what is a normal amount of Gradle config time?
Yeah, that's a good one. And I think I couldn't find a place where someone in Gradle docs or elsewhere stated what it was a reasonable number. So for me, it's something I developed an intuition through just working on a lot of Gradle projects. And so I wanted to kind of share my kind of rough ballpark of what I think is reasonable. And then the idea was that this post would spark a discussion, and people would call out like, "Oh, I'm completely wrong," or maybe I'm like overly generous. And I think I got feedback in both directions. And so the thing that I came up with is that it should be less than 100 milliseconds per project. So as you are hopefully aware, Gradle can let you have many projects within your project. So each one of them could help you modularize your build, and you hopefully have done some of that work. But the idea is that it should configuration time should scale proportionally to the size of your project. And so if you have very few projects, configuration time should be blazingly fast. And if you have a very large project, because of the way Gradle works, it does configuration phase serially today. It will effectively scale the number of projects, but like the per project thing should be kind of a constant. And so I picked 100 milliseconds as a rough ballpark, and I think that's kind of where the discussion started. And that's where you ran it on a little benchmark on a Kotlin conf app, and you got a number that's bigger. So I think that sparked the discussion. So maybe you can walk through of like what you thought about your configuration time before, and then what you felt after you ran the first benchmark.
I don't think I thought much about configuration time on its own before. Generally, the project is still small enough that we don't have to worry too much about anything build time related, luckily. Obviously, for release builds, it doesn't really matter at the end of the day how long they are. Like, we don't run them too frequently. So just by the size of the project, we're kind of lucky on times runs builds and things like that. But of course, if it's doing weird broken things, I would love to know about it. Which is why I was interested in profiling it and just seeing if there's like any Gradle config that might be incorrect in there in some way.
Awesome.
And of course, like
I think
sync times and things like that. If any of that speeds up, like obviously that's always a nice like UX improvement day to day.
You're not going to complain if it gets faster, is what you're saying.
Yeah.
Cool. So I figure one thing that we might get started is just kind of like, how would someone, learn if their project is in the good spot, right? So I figured we could jump into your project and just kind of do some, vague conversations of like, what to look for. I think one thing that is important to note here before we kind of jump in further is Gradle has a concept of dry mode or a dry run. And what it does, it effectively skips the task execution phase. And it's a really handy tool for a lot of debugging. So if you open your terminal, for example, in your IDE, we could kind of run something like, let's say, Gradle W build, or not build, let's take a smaller task, maybe let's say test. and then you do dash dash dry dash run. And if you just run this, what we'll get is essentially Gradle running the initialization phase and configuration phase, and then serializing the configuration cache, and then stopping, and then giving you a list of all the tasks. So the things you can kind of learn about when you're doing this is like, one, it's really handy for measuring things. But the other thing that's helpful is you can actually see what tasks would have run if you wanted to, know if your like task dependencies are set up correctly, or if it's doing something funky and you're like, well, that shouldn't happen, that task shouldn't run. This can be a handy debugging tool to just kind of go backwards and like figure out why something ran. But the part that is really handy for us is being able to kind of measure just the part we care about. That the task execution of your build is important, and it can be measured and it should be measured. But I think at this case that we want to focus on is just configuration. Dry run is super, super handy to be able to kind of know whether it's doing the just the bits that we care about. So like then we're not measuring other things like Kotlin compiler and other things that might run. Yeah.
Yeah, makes perfect sense, and of course we can also see, like for running tests, for example, which modules would have to be compiled based on the tasks here, which modules actually had a test task that can run any kinds of tests. So all of that is here, and we also see that this took 16 seconds for a start, and it wasn't a cache hit before, but now supposedly we have configuration cache for this.
So if you go back up and you run exact same command again, that's hopefully a good way to demonstrate like why you want configuration cache. Blazingly fast, and that's kind of what you want. It's still, I would say from intuition, it's still like a tad slower than I would expect. You're probably running on like an ARM Mac, I'm assuming.
Yeah.
So I would expect this to be like maybe half of that time in general if things are good. So there's probably like either cache entries are a bit on a larger side, or there's something else, but like it's in the right ballpark, which is I think the important part, right? It's fast enough where you're not going to notice, right? If it goes from 500 milliseconds to 300, you're not going to notice a difference as a developer.
Yeah, it's so I mean I have a couple IDs open, the emulator running. I have the stream going and screen sharing into the call that we have. So
okay, you're keeping
might just
busy.
be
Maybe this is a good number. Cool. So the other thing that is helpful to know when you want to be able to kind of measure the configuration phase is that when you have a hit, obviously you're not measuring how long it takes when you don't have a hit. And to ensure that you have a hit is you can delete the configuration cache entry manually from your disk. So if you do remove command rm,
which is basically just in here.
Yeah, exactly. Yeah. If you just nuke that directory, and then you run it again, you'll see that now we have a configuration cache miss. And so that allows you to kind of like measure, what it would take. So if we'll... Yeah,
interestingly, though, this was only 2 seconds this time.
Yeah, so that's the other thing maybe we should chat about is when you're doing this manually, you're going to have a lot of noise. And that's because, one, your machine is doing a lot of things in the background. You're potentially initializing Gradle daemon for first time. You might be modify the KTS file somewhere. And so the first few runs tend to be noise. And so as we're doing it here, we can kind of, run it 100 times or 20 times and have a number, and that would give you a very good idea of how slow your configuration phase is. But wouldn't it be nice if we could have it in a more automated way, where you don't have to do this manually? And so maybe that's where we can talk a little bit about Gradle Profiler.
Yeah, clearly what we're doing manually is some kind of benchmarking here, and it's roughly 2 seconds, but it's probably hard to work with roughly 2 seconds as our measurement.
Exactly. So I believe you've checked out a copy of the Gradle Profiler and you have it built. Is that right?
Yes, I think so. This is where I'm getting slightly lost on the terminology. I have copy-pasted a bunch of things from your blog post, and they produced results.
Let's look at the copy-pasted scenario first.
Yes.
So so the thing that this does is essentially a set of instructions of what we want this Gradle Profiler tool to do. And what we tell it to do is run a build command or task specifically. And a build task is kind of more encompassing than the one we ran before, which is test. Build will trigger test, it will trigger compile, it will trigger linters, a whole assortment of things.
I mean, I guess we could change this to something that I know that I run often, right? Or
Yeah, exactly.
is
Like I think
it...
that's
How much does it matter which task we're picking here? Whether it's build or test or like a specific like Android debug run or any of these?
yeah. I think it's the important thing is you should optimize the things you care about, and so picking just the right task is important. In a sense of like you can go and optimize the bejesus out of a task you never run, but it won't matter at the end of the day because you will be doing, the work that you don't actually care about. And so, generally, when you measure things, you want to measure the thing you care about, and that's, picking the right kind of targets and things like that. So, picking a task like, run or assemble or test is a good way to do it because one thing to kind of note is that configuration cache um, I mentioned is roughly the same cost. It's a little bit of a lie because what Gradle does, it only serializes the tasks you've asked it to run. So, for example, if you say, hot run JVM, it will actually initialize or it will create all the tasks, but then only serialize the ones you kind of cared about. And so at the end of the day, you kind of end up doing less work because Gradle knows that it doesn't need to, take a test task and serialize it because you asked for a hot run JVM, which is just building the thing and executing it. So it's you kind of like have to know what you're measuring as well a little bit, but yeah, picking something like that can be good. And so this is kind of a scenario where we tell it configure the project. It will store all of the configuration cache entry because we have a dry run, but then we won't execute anything. And then the very final line there on line 6, what it does, instead of manually having to delete that every time, there's a kind of a shortcut in the tool that allows us to see like, oh, actually we want to simulate what it looks like if you have it, no configuration cache hit, and so it deletes it for you.
Yeah. So I guess we can try running this a bunch of times and just seeing how long configuration takes.
That's right. Let's give that a spin. So I think you probably have a copy paste somewhere of the way to run the profiler, and so we can kind of get a sense of that. Or sorry, not profiler, benchmark.
Yes, let me... So this is still with the Gradle profiler command, right?
Yes, Gradle Profiler. So Gradle Profiler is deceivingly, it does two things. It does benchmarking and profiling. So the part that we're going to look at is right now is kind of benchmarking, which is doing the thing that we're doing manually in the command line over and over again.
Okay, this is the part where I fish out all the comments that I generated based on your blog post. I think this is essentially what we want.
You probably want to change the warm-ups and iterations to maybe do a slightly larger number. But
yeah.
yes, roughly that we can run and then see.
Yeah,
normally
so
for
we're
warm-ups,
running...
I'd say at least 2.
Mm-hmm.
And then
And we
iterations
can do
probably
like
be like
10 or something.
4, 5, 10, yeah, something like that, because it's pretty fast, should be quick.
Okay, so we're running Gradle Profiler, but we're asking it to benchmark. We're running it in current directory. We have our file, which contains the config, and then just those numbers. Let's see what happens. It downloads Gradle.
Yes, so the reason it downloads Gradle from scratch again is because Profiler wants to control the environment in which it's running so it can actually measure stuff properly. It sets a custom Gradle home directory. So normally Gradle stores a lot of things in your Gradle home. Oh no, are you offline? Well, it can be. You're streaming.
I hope not. Very interesting. Let's just run it again.
Oh no, it's still doing things. What is that? Okay, well, guess let's try again and see what happens. Well, that would be a very short stream if we learned that we can now run the the profiler.
Why is that possibly happening?
Caused by could not read metadata from blah blah blah. Let's maybe try running again, see what happens. If it blows up again, then we dig deeper into understanding.
I guess it's just, I mean, I can delete the previous directories for a sanity check.
Yeah, Gradle user home is that directory there? Maybe let's delete that one as well.
Yeah.
So that, as I was saying, like one of the things that Gradle does is essentially it creates a separate Gradle home. Normally, it's in your home directory dot Gradle, and that's where Gradle stores all of its like metadata, downloaded distributions, versions, and so on. It puts it in a separate directory, so you wouldn't pollute accidentally if there's a different Gradle instance running, or maybe you've done some work before. So it puts it in this separate directory, so then it can like have more control of what the outputs are.
Yeah, just have like a clean distribution.
Exactly.
Unless I already ran this earlier, and then we need the like meta step of clearing the
Well, in theory,
the outputs of the profiler itself.
So I'm a little surprised it does this, but I guess we'll learn what happens when it executes. Hopefully, this time it actually succeeds.
Now it just looks like we're stuck on the download, which is even stranger.
So it's demo gods, not in our favor here.
Okay, let me catch up on the chat in the meantime.
Sounds good.
Configuration stage becomes slower the more modules the project has. Yes. I would love to know how to pinpoint the bottleneck specifically for the configuration stage. That is what we are attempting to do. And Martin linked the blog post for us. Thank you. I was lazy and didn't send anything into the chat. We are. Oh, there we go.
Okay, it's back to business. Good.
It just
kind of roughly tells us what it's doing. I think it was trying to stop some Gradle demons, so maybe there was some stubborn demon that didn't want to die.
I could have easily had a couple dozen of those. that would not be surprising.
Yeah, so it kind of lists, what it's trying to do, and then, you can kind of see steps. So like the warm-up build essentially is a build that is exactly what you asked it to do, but it will not take those into the measurement, just because they're not, tend to be noisy, right? Like it's the first time it downloaded this daemon, first time it started this daemon, and so on. So it's like now getting the data that's not really helpful. So what it will do is then after a couple of these warm-ups, it will jump into the actual measured builds.
Oh, I'm sorry. I didn't realize we were covering the terminal with our faces. Thanks for pointing that out.
People don't need to see that. That's okay.
So when it's doing the warm-up, like, could it be downloading Maven dependencies and things like that?
Yes, it will do all of that stuff. So like
okay, this is going to take a while then.
Yes. Yeah. It's definitely the first few runs can be painful. Like when you're tweaking stuff later, it will become nicer. So hopefully the second time we try something, it will not take as long as it does this time. So we'll just have to fill this with our wonderful conversation.
I'm just gonna see if we can actually see the download happening.
It's not downloading, huh? Or not intense amount of download.
Well, it's not super obvious anyway.
Yeah, I'm not sure. I mean, it seems to be doing something. Hopefully it is. You did run it before, so we know it works at least some of the time. Here we go. Second warm up build.
Oh, actually.
Build. Oh, now it's cooking.
Bam, bam, bam. Yeah.
All right. So now this will pull out some results, so we can take a look at them.
Okay. So we have a CSV, which is very straightforward. Basically, we're around 1 second for configuration time, right? And we have the same thing in HTML form, which I will attempt to open in a correct browser and move here. Let's see. So there.
Yeah, exactly. This is awesome. So the nice thing about this UI, it also kind of gives you an idea of like how much variability there is, because you can kind of like very quickly glance. And then of course you can look at the standard deviation to kind of give you the actual numbers.
Yeah, so we're pretty close to like 900 milliseconds, basically.
So now one thing to kind of like tell the viewers, which they probably don't know, is how many projects do you have in your project?
Yep. Let's do a quick count. I guess we can also do right. Just
You can do
projects?
that, yes. Or you could go to the settings.gradle as well. That would also show it. So you
Right.
have
I think
5.
it's just 5 so far.
And then we have the number, which is roughly 1 second. So we're, I guess, in a ballpark of 200 milliseconds range.
So it would be
which
nice
is
if we could shave half of this off.
exactly. So not to say this is like terrible, but it's also not amazing as well, right? There's definitely like a tiny bit of improvement. And one of the things that I kind of did offline before we kind of went on is I went through your build and then tried to look if you're doing any custom logic, custom build, anything. And the reality is that you don't do any of that at all, which is awesome.
Very,
You're
very
able
little.
to, yeah, exactly. Very clean
Yeah.
build. Like you're pretty much only applying other plugins.
I think we have the release tasks, which is like this small Gradle script, which does a bunch of like parsing text files and then replacing versions with regexes. But outside of that, it's applying plugins and then doing a bunch of configuration on it. And I think that's probably most of our modules.
Yeah, so I think that roughly puts it where that you don't have a lot of levers to pull other than apply or not apply plugins, right? So that's kind of like a blessing and a curse. It feels like you're kind of roughly doing the right thing, but it's the question is are you happy or not happy? And of course, it can always be better. But to kind of for some examples to kind of make it a bit more let's say visual for people of what kind of problem we might find, I figured it might be helpful to run the build task in the profiler. So if you go to the scenarios and you move back to build, and then now instead of running benchmark, so benchmark, what it does, it just runs that in the loop and does the deletions of the directory and then runs again. We want to try doing a profiler right now. So if we could move over instead of benchmark, and then hopefully you can copy paste the task, the thing, but essentially it's just dash profiler and then async, I think dash profiler. I'm trying to remember exactly.
Oh yeah, I have that somewhere. Basically
Yes,
just
exactly
this and everything else is the same. So instead of benchmark, we do async profiler.
And you can use the default for warmups and iterations. You can actually delete those arguments. Gradle will just pick whatever it thinks is reasonable. Yeah.
Okay.
So let's do that.
As we're going through this, can you talk about what our profiler choice means?
Yeah. So because this is Java, there's a lot of options and a lot of choices for you. And so Gradle Profiler is integrated with more than a single profiler. So you can essentially kind of choose your poison. I have worked at work in my corp world a lot with YourKit, which is just one of the profilers you might use. But there's kind of a variety of the ones you support. So I think the ones that they do that are the nice one that you picked as async profiler is entirely open source, so you don't need any licenses. You don't need to pay for that software. You're able to just kind of like try it out, and then the output of it opens directly in the browser, which is super handy because then you don't need any special tools. The downside is it's not as thorough as some of the commercial tools, but it can be like really handy. And then I think other ones there's JProfiler. There's YourKit that I mentioned. There's Java Flight Recorder and so on. So if you look at the Gradle profiler, GitHub, you can kind of see that there's a list of the ones that they support, and you can kind of like pick your things that work for you. And then so additionally in top, profiling allows you generally to, people tend to focus on a CPU measurement, but the Gradle profiler also allows you to measure things like memory usage as well. So you can
have like a heap dump.
Memory heaps. Yeah.
Chrome trace also sounds very exciting.
Yeah, exactly. Yeah. So
the number of things that you can use Chrome developer tooling for is it's always surprising.
It's a gift and keep on getting. Like I worked in Chrome team. That was my first job at Google, so I still have a lot of warm feelings towards a lot of things that have been built out for Chrome in particular.
Yeah, I think
like our
measurement
is completed. Done. So we get to open open the traces now. So if you could open, let's see, which one would be interesting? Maybe let's look at the flame graph, the raw flame graph in your
In a
browser.
browser. Yeah.
All right.
So this is an SVG, which
yes,
is surprisingly
it is an interactive SVG.
complex and surprisingly interactive. Yeah. I guess we can zoom into it and.
Yeah. So let's we can like talk a little bit. This can be super intimidating when you get started.
Yep.
Like when the first time I opened this, I closed it and not looked at it for several months, just because this is like a wall of words and text that don't mean anything. And so hopefully, as we chat through, we can give you a little bit more encouragement that if you look at it long enough, there will be something to find. And so, you know, this async profiler in particular is not the most user-friendly tool, but it's free. So, you know, we get to use it without paying anyone. And so if you kind of like learn the places and things to look at, you can kind of start looking at things. So off the top, kind of like at the very, you know, or at the bottom of the stack, or what is a flame graph? Maybe I guess. Do you want to tell folks what flame graph is? Maybe you can kind of
let's start with my understanding of what I'm looking at, and then you can add other info and correct me where I'm wrong. So basically, we've executed something with Gradle. We ran through the configuration phase, and we were sampling, I guess, roughly like every millisecond or so, based on having 1,000-ish samples. We were looking at what our current stack trace is, like what function, what call tree our application is currently in. And that's what we're visualizing here. So x-axis is time. On the bottom here, we just have all samples, which is this 1,000-ish number. And then we can see that within the main function, I guess, that we entered, we have like a thread run at the base here, which accounts for 45% of the execution time. And then there's another big chunk of 50% of also running a thread with some task in it, but somehow more natively, apparently. It has a lot of natives in it. And yeah, like we can scroll up here, and then we can see the smaller functions that we entered and exited over time. So we went into all kinds of Gradle related functions, and we serialized a bunch of things. Apparently, we see a lot of coroutines here, and all of these are zoomable in this SVG somehow magically. So if you want to see like what this function call actually contains, we can click it, and hopefully it expands. So now that's like here as like a reference point in our graph, and then we can see even more details of hopping into deep call like call stacks and then exiting them. And I guess we're looking for like long chunks that we can identify and then understand how long those took and like try to find suspiciously long things. Like if we put a thread sleep somewhere, we could hopefully see that as like a large line here.
Yeah, exactly. That's a very great summary. I think one thing I was going to add on top is that this kind of gives us appreciation of how deep the stacks are in Gradle. Right, like a single thing that you're executing a task is 100, 200 stack traces deep. You accidentally clicked in exactly.
I was gonna say. Yeah.
But like, let's go back a little bit. So if you scroll down to the bottom and you click on the very all, so that this will expand the view again to see everything. I was gonna highlight that's the native side of things. So what you'll see is the C2 compiler, which for folks who have not dug into JVM a lot, is essentially Java pre-compiling the code that it's running. So this whole other thing is running on a background thread, and could essentially, if you heard of just-in-time compilation, this is roughly what's happening. So Java, in order to make that application run faster in the future, it essentially runs a special mode that takes your bytecode and optimizes it further so it can run even faster the next time you run. So normally with Java applications, the more times you run, the faster they become, because the compiler essentially stores extra metadata for you to be able to like execute faster. And so this is like what's happening. Like you're essentially looking at kind of like Java trying to help you here. But the way Gradle profiler is set up, it kind of this is the part that we don't necessarily care about how much, but like it gets measured anyway, just because you might learn that like, oh, why is this compilation taking a long time? Maybe you picked the wrong type of compiler. Like C2 is one option, but there's alternative options. So then you can start tweaking JVM arguments and things like that. In this side of things, you can also start seeing garbage collection potentially as well. So like you might learn that, for example, if you don't give your project enough memory, you will also see a thread of the Java garbage collector as well. And you can be like, okay, like why are we spending, n number of milliseconds in garbage collection? Maybe we need to give it more memory.
Yeah, there were actually questions in the chat about like how much memory we want to give to. I think it was one daemon or the other, or it was various components. Yeah, like Gradle, Kotlin daemon. Like, how much memory do they probably need? Was one of the questions. And I guess.
Do you want to take a stab at answering, or do we kind of like how do you want to approach that?
Do you have? I don't have a brilliant answer for this. When something starts complaining for me, I give it more RAM.
Exactly. That's kind of what it is, right? Like there is no one answer. Each project and each usage of within the project is quite different, and so there is such thing as too much memory, because as you give Java more memory, the garbage collection becomes more expensive because it has to go through more memory to like deallocate and so on. And then also you're wasting memory that could be allocated to your Chrome or other things on your system. So there is an upper bound. The lower bound is usually kind of the things to know is if you the easiest way to know if you need to change something is kind of like looking at a Gradle build scan and how much time you are spending garbage collecting. So anything more than a couple of seconds is usually a problem, right? Like if you're spending more than a couple of seconds garbage collecting, you most likely are dropping performance because you're now spending time, reclaiming that heap and giving it back to something else. So I would say like the
so you
best
probably
way to
need
know how
more
much
memory in that case.
Exactly. And so the best way to know is just kind of like measure, right? Like you have a tool in your hands that we just talked about is benchmarking. Give it a different amount and then run a benchmark and see how it affects your build. And then, you kind of scientifically can prove that this is the best amount for your project and your build. Yeah. Cool.
Yeah.
So are there any other questions that people have, or do we jump now to some other things that I was going to highlight?
I think we can keep going with the flame graph. Okay. I have a question, which is,
Go ahead.
So we have this native compilation part, and this runs on a background thread separately, as you mentioned. So is what we're seeing here actually happening like one after the other? So is like all this green JVM, like Java call stack parts, do these happen before the native compilation, or is this visualizing two otherwise parallel threads? And
yes, so the flame graph in particular, this view does not give you a sense of when something ran, but it only gives you the percentage of time it took. So it's a good tool to see cost, but not timing. For timing, there are kind of alternative views of it. But what this is good for is like, like if I happen to spend a long time in a single function, this flame graph view is very good because if you kind of look at the way the stacks are built, the largest chunks are always to the left, and then the smaller ones go to the right. And as you go up, essentially, this gives you a very easy way to find where your bulk of your time is going. And so to answer your question is like these things are running in parallel. And this is just showing all the threads total combined. But then for each thread, you can start digging and figuring out how much of that thread's time was spent in one thing or another.
Right.
So you can kind of see if they're actually equal time-wise because roughly the compilation ran while you were running the build. So that's why they're almost the same size.
Yeah, makes sense. And then I guess there's a lot of tiny threads in here in the middle, which we can basically ignore, but Gradle ran like a bunch of very quick things compared to these.
That's right. And then if we were in a kind of like execution phase, there would be more threads because the configuration phase generally is like single threaded for most part. This is kind of like a simplified scenario as well. It's I would say easier entry to profiling when you don't have to also think about threads on top of performance of a single one.
Yeah. So what we're interested in here is probably only like this green
Exactly.
bit
Exactly.
on the left. So we can, as a start, we can at least filter into that.
Yes. So another thing I was going to call out here is that because we're running the configuration cache on, um, it changes the way Gradle works in terms of execution. So if you ran this build with configuration cache off, you would get different stack traces, but you might end up doing similar work. It would just be under different places because kind of Gradle has different paths of like, okay, first I need to serialize these tasks, then execute them. In the other case, it kind of like starts executing right away, but then it has to compute task inputs kind of lazily as on demand. So the stack trace would kind of move around, but of course, because you have CC, that is the path of how your users or people working on this project run. So this is the right thing to measure. So that's kind of like another important things to know is you should only set the flags that are representative of your usages, because if you change flags and that's not how it works, some of the stuff might shuffle around and you might be not measuring kind of the right thing here.
Yeah, and I guess if you have any kind of custom configuration in your project, like that you're controlling through properties that you're passing in with your build commands and so on, like you also want to set all of those things very similarly to how you would do it day to day in the scenario file.
Yeah, exactly. All right. Well, let's scroll up a little bit. There is one thing that I was going to highlight just because there's, I would love to show people at least one thing that we found in this progress. So if you click on the left side, the binding codec back encode, like one of these, yeah, just to like
Yep.
focus on this stack, just
Because most
there's
of this just says, as you're looking through it, it just says Kotlin coroutines Gradle internal, right? So it's
yes.
like quite hard to figure out what you could possibly affect out of all these things that are happening, because it just
And
seems like, well, it's normal Gradle internals probably.
yeah, that I think that's part of the tricky thing is like the way that Gradle works. Like, if you put something into DSL in your build.gradle, and then that causes a lot of time, um, it will get attributed to most likely that plugin and not to your build file, because the way it's executing, right, is going to run. So like you have to be pretty careful. It's not always like, oh, it has org.gradle in the name, that means Gradle's at fault. And here we'll see an example. So if you look at the third big column from the left,
Like
yeah,
here.
if you keep scrolling like a tiny bit up, and you'll see Mike Pence in the name there. Um,
Yes.
yeah. So what I spotted, and if you kind of
I
like
guess we can, yeah,
hover,
like
yeah,
hop
exactly.
in
If you
here.
roughly look at that area, we kind of see that this is a plugin that I found that your project applies, which is a plugin that builds a UI to show information about the libraries that this project is using, like licenses and things like that. Um, and here we can kind of see that it's actually impacting your project quite a bit. So if you kind of hover, I think it tells you the percentage of time it's spent.
It's like 5%, 4.5. Yeah.
Yeah, it's a fairly sizable amount of time to spend on on like a single project. And so this is an example where you can kind of be like, okay, like now this plugin is spending this amount of time. If I remove this plugin, how much gains would I have for my benchmark? So that's like one option. Like some of these plugins are pretty easily removable, and then like let's do that in your case as well. I think we did not run build command benchmark yet, so we might need to run that first, and then we can do the edits on the file as
Right,
well.
right. So we want to, yeah, let's go back to our benchmark command, and because we updated our scenario, then this should be fine.
Yes. Yes, and hopefully it's not going to take forever to run. But the idea is we can go to the shared project that you have.
Yep.
That one,
So
yes.
basically, like these usages.
Yeah, we'll want to take that out once the
Yeah.
benchmark completes.
Yeah. So
And
essentially,
just
what we're doing is we're applying this, and we have like a small configuration block which is setting enums, and I mean we're setting a file. Like maybe some kind of IO is happening, or something like that in the plugin initialization.
yeah, I generally wouldn't blame you on this one. Uh, I think in my mind, this is more likely going to be a plugin doing something that's probably useful work, but it is also like, is it necessary work? So okay, so we ran, and we'll see it's like 300 something. Yeah.
I guess we can just go to CSV, right?
Yeah, so it's roughly 300 something, and then I think we'll later open it in Chrome so we can kind of compare. And then now let's take that plugin out of the file. So essentially, let's take out that. Yes, and there's, I think, these imports, and then the application of the plugin, the top one. No, not
almost.
that one. Yes, and then there's, I think, one more. There's a lib library that's included as well. That's from this. I don't know if it's going to affect.
Assume that should be fine, right?
It won't affect the build. I guess we're not building, so it doesn't matter. Yeah, so we can run the benchmark again now. Maybe once you should probably not run sync at the same time.
All right.
You're running sync.
Yeah, I was gonna say I can tell you my fans just turned on.
Yeah, so that's another thing to pay attention to, right? If you have thermal throttling, you're gonna get different results, and so then you're not really measuring what you think you're measuring.
Yeah, which also means that you might not want to do your benchmarking while on a call and running a live stream.
That is true. So the data we're going to show is not necessarily representative. All right, I think it's finished. So let's give that a spin. So yeah, while it's running, when I ran it on my side, it roughly saved about 700 milliseconds, and we'll see if it matches the thing. And here's to say is that, this plugin is providing value, like it's doing a thing that
we are definitely using this plugin.
Yes, and so you kind of have to pick and choose, right? And like one thing is like, could this plugin be optimized more? But it's not really like a user you should be necessarily fixing it, but like highlighting to the plugin author, like, look, this is how much it added to our build, is potentially a useful thing to kind of like highlight. And so then they are able to be like, okay, like, where is the time going? Maybe you can provide them a flame graph, and they can kind of like look and figure that out as well. So we'll see that's like in the low 3. So if you open the browser, it might be easier. So I think this 5 and 3 are the ones.
Yeah, I think 4 was the one that I canceled. So let's open 5 and 3 in the browser. I guess we can put these side by side. Or can we? There we go.
Yeah, so I guess we see 400 milliseconds roughly decrease. And if you run them like more samples and stuff, you can get slightly more precise measurements. But the idea is that, each plugin comes with a cost. And the idea is you as a user of a plugin have to be aware if it's like a reasonable cost, right? You as a user in there where we looked, you're not really doing anything interesting. You're setting up the DSL, a couple of options, and it's doing its thing. When I dug into the traces, and if we go back to your browser with the traces, if that's not gone, it's still there.
Mm-hmm.
If we scroll up, I'm trying to see if we can spot it easily.
Fetch bomb files?
In one place, yes, that's the one. In one place, I found that it's parsing XML files. And it's parsing XML files during the task resolution. You'll see regex patterns and stuff there somewhere. Scroll up a little bit more.
There it is. Yeah, I'm not sure.
Yeah, so there's like regex, and it's doing XML parsing. And if you dig enough, you'll find that what is happening is when this task is being serialized, some of XML gets parsed. And when XML is parsed, it's not a cheap operation, right? You're doing a lot of I/O, there's regex and things like that running. And so maybe there's room for optimization there. It's not clear, right? Like without having spent time on this plugin, having a good sense is difficult. This is clearly fetching POM files from all of your dependencies so you can look at the licenses block and collect the necessary things. The question is, could it be doing that in the task rather than in the configuration phase? So, the thing is, the configuration phase is roughly serial. And so if it's doing that work in configuration phase, it's blocking all the other work from happening. If, for example, instead of taking and parsing these POM files, it could somehow, and again, I don't know if it's possible, if it could just get a list of these files and then parse it during the execution of the phase, now you could be running in parallel among other tasks. And so you could potentially, improve your performance of the build, end to end. So it's hard to say, but that's, I think, the TLDR is like, these are the kind of things you want to look for. Are there some funky looking things to kind of like see? And so, there's no golden rule like, if you're gonna do this one thing, it's gonna improve your performance a lot, unless sometimes you find these things. And then maybe we can talk a little bit about Androidify and the post that I wrote that triggered
Mm-hmm.
us to talk about this in the first place.
Yeah. Before we hop over there real quick,
Sure.
so here with this plugin, basically what you would be want to be doing, well, what Mike probably wants to do, if he wants to take a look, is basically like look at dependency collector and then fetch POM files and like see what that function or task is doing.
Yeah, exactly.
And see if that could be moved from configuration time to execution time.
Yeah, and it's hard to know. It's possible it's required because it's relying, like, it looks like it's doing some resolution of dependencies, which might only be possible to be done at configuration time. It's possible, but I think,
like maybe the Gradle info is not there later on, or
exactly. So, and that could be, a feature request to Gradle as well, right? Like, could there be a way to do it during task execution time and stuff like that? But, again, I'm not blaming the user here, but it's just like, it's taking time, and then you as a user have to choose, is this time worth, the thing you're doing? There's something else over there, model building as well. So, if you click on that, I've not actually looked at that part, but we can also see what's doing there.
So it sounds like it's probably fetching the entire POMs and parsing them, and maybe, as you mentioned, it could just, at configuration time, the plugin could just prepare the list of files that are POM files, and then it would have that info later on so that it can actually grab them and then read their contents and so on.
Yeah, exactly.
Yeah, there's definitely IO here of some sort.
Cool.
Yeah, let's move on to the other example then. So let me, I guess, grab your blog post first.
Yeah, we can walk through that. It's a very short post, so hopefully easy enough to understand.
And I also have Androidify here if I haven't lost it yet. Very good. We have so much space here.
Cool.
And our face isn't covering up the entire thing. Good.
So the first post I wrote is kind of like the thing we just discussed is like, find out how much time your configuration phase is taking. And hopefully now people have confidence that they can do it for their own project. Then the next question is like, what do you do about it? Is there a way to make the plugin you're using do less work in configuration phase? And this post is kind of like me accidentally stumbling into the fact that Androidify, which is one of the apps that Google has to kind of demo Compose and a lot of other tools that we have, it allows people to, we're able to improve our configuration phase very, very drastically. And so walking through, what is that thing that changed? So specifically, Spotless is a tool that allows you to do code formatting. You can invoke KT formats, KT lint, XML formatting, all sorts of things that you can kind of improve. And so here they have kind of a setup where they essentially say **/ KT. So it's like pick up any Kotlin file anywhere except for the build directory, which, at the face of it looks very reasonable. It doesn't look like a very silly thing to do. But the thing is, putting it *// the way this plugin kind of implements it, it effectively has to consider every single file in your project or every single directory at least, to see if there's any Kotlin files in there. And that might become very, very costly, right? Imagine you have like some, extra metadata directories or some sample data or anything that causes, a lot of directories to be created, is going to have to go through and do that. And additionally, if you have a sub-project, so if you have a project inside of another project, now you're actually double including as well. And this project does, if you look at, I want to say core maybe, or feature, one of them has sub-projects. Yeah, so core. So now effectively you're including that same KT file twice, which is not great, right? You're essentially forcing yourself to test that several times. And if you have more nesting, that will be 3 times and so on. So there's kind of like a layer of extra thing. Like if you put it only just in your root directory and your root project, may be reasonable, but even then you have to like measure, make sure you're happy with it. But the thing that I found is we can be a lot more precise. We know that all of our Kotlin files are in source directory, and so simply we can just specify that. And similarly, for Kotlin script directories, we also don't need to say look for them anywhere. We know that they're in the root of each project, and that allows us to do that type of scanning also in a much more precise way. And so to
And
kind
then
of skip,
XML the exact same way at the end here.
yeah, exactly. Exactly. And to kind of skip and spoil a surprise, if we look to the blog post, this small looking change actually made it, trying to remember, 67% faster, the configuration phase, which is bonkers to me. Is like you shouldn't have low hanging fruit like that. So it's an idea of the kind of things to look for, and you can find this cost in the profiling. So when I did the original post, I found that Spotless plugin, when it's doing the consideration of which files to include, it actually checks whether the file has a normalized ending, so like a new line character at the end of the file, which is a reasonable check to have, but it shouldn't really be happening during a configuration phase. And so it can be, pretty costly, when it does things like that. And so giving it a much narrower scope means it will do it on much fewer things, which will mean that your configuration phase is faster. So, could Spotless do a better job? I think so. At least from looking at it, they could do a better job. But like also as a user, I did kind of tell it like look for it anywhere. So it's kind of like a combination of faults. I would say it's not just like one person, who could do better.
Yeah, and in this case, when the potential difference is so drastic, I guess it's a lot easier to spot this on a flame graph, right? Like this would be
Exactly.
a huge, obvious block that just immediately
Exactly.
pops out at you.
The further you optimize, the harder it is to spot because the slices get smaller and smaller.
Yeah. So for example, like looking at what we've seen with the Kotlin Conf app project, there aren't any like obvious huge things that could be improved. Like the one thing we found that was from a plugin at all was basically that block so far. I assume if I had a fancier profiler like your kit, I could start filtering out all the coroutines and Gradle things, and it could give me something like what's the top like package and class that you're in that's not something internal but maybe a plugin.
Exactly. Yeah. A lot of these tools do that. They have bundled rules of things that they kind of know it's not your code. And that can be very, very helpful because you can kind of see these flame graphs be a lot shorter, so you don't have to scroll up and down as much. So yeah, it definitely has other things I'm going to mention is it also has things like it can track the number of exceptions thrown. It could track I/O access. It could track network access. It could track your heap allocation. So like, as you pay for these commercial tools, there are things that you can do that you wouldn't be able to easily do in a sync profiler. But the idea is, could we, as a community, go and like find these type of problems and like highlight it to the plugin authors, and we find things in Android Gradle plugin. Like over my time, I've definitely fixed several things where we're like doing I/O and configuration phase when we could just like delay it. And so, I would like to encourage anyone who's watching this to just kind of go out and see who you can help by, if you fix one plugin, you're most likely going to fix, thousands of applications because that's, blast radius is huge.
Well, especially for AGP.
Yeah, exactly.
Yeah. This was linked as a related issue in the Twitch chat. So basically,
looks like people have known since 2017.
Yeah, basically a request, I guess, to include the like proper targeting for finding source files with Java back then, but I mean, it's been
The sad
going.
part is like if you do a search in.
Oh, there we go.
Someone
Now.
my thing. If someone looked at like the include *** /*KT, like it's everywhere in GitHub. Like there's thousands of repositories that are doing this wrong thing. Which at this point I feel like then plugin authors gotta do something about it because it's not something that is if it's so easy to make that mistake and many people do it, I feel like it's a little bit of on the plugin author to help everyone to improve that.
No, I
You
guess
need to do
this
some
needs a bunch of
escaping.
escaping, yeah.
Yeah.
I don't even know how much.
And then you have to click on code, I think, instead of repositories.
All right.
Yeah.
Roboelectric for a start.
Yes. So,
Yeah.
there's obviously big projects, that have this, and so, there's people who know what they're doing, right? Like if you look at the name, there's, familiar names in the list of people. And so like
Yep.
if folks who know what they're doing make this mistake, like I think the tool should warn you at minimum that you're most likely doing something that you don't intend.
Yeah, I mean this looks like what, hundreds of PRs right here.
That's right. So people in the chat can, pop in and do some good quality work.
Just for this one specific fix in one plugin's config. Yeah.
Exactly. Cool. Well, I think we're roughly at the time when I've got to bounce and do some other stuff, but hopefully this was interesting and useful to folks. And then, maybe in the future we can figure out some other topics that are, intersecting in the world of KMP and JetBrains and Gradle.
Yeah, thanks so much for joining and teaching me some things and teaching our viewers some things. I'll follow up with Mike about the plugin because it's the one problem that we found in the app so far. So that should be fun, and hopefully there can be a follow up about that on socials at some point. Yeah, I think that's pretty much a wrap. So thanks
Awesome.
everyone for joining. Thank you for explaining all of this to us. And yeah, we'll see if we can do something else next time.
Awesome. All right.
Yeah.
I'll talk to you later. Bye.
Bye bye.